I know it is not so easy. I'm tired as you, so keep it short and we can start advertising the beer after party. Yeah, so my name is Rafał Bigaj. I'm from IBM. I'm responsible for what's on Pipelines product there, which is part of Cloudpack for data. And this particular product is based on Tekton Pipelines. And today I would like to share my experience with making Tekton production ready. I don't know if there's anybody of you who is using Tekton currently. I don't see any hands, so I assume nobody. But Tekton is quite new open source project. I will mention about it and describe it to you. I spent 2 last years making it production ready in our software and collaborating with open source community to improve it in many places. My professional experience started 30 years ago when I wrote the first basic script on Commodore 64. Since that time, I played with a lot of technologies. Currently, I'm mostly in Go and Python because of my expertise domain, which is AI lifecycle, MLOps, and machine learning as a whole. Beyond the professional life, I really like traveling. This is the preview of our family trip last year. We traveled across more than 3,000 kilometers to Albania. Unfortunately, my children, I have 3 daughters, are now teenagers, so the situation in a car looked not so bad as on this picture. So I don't know if you are familiar with such a questions. Daddy, how much longer? Repeated over and over. Daddy, are we yet there? Daddy, yeah, I remember that very well from the previous years. Currently, as I mentioned, that is slightly different. I will go back to that topic in a second. In this talk, I will tell you a short MLOps story because that's my, as I mentioned, main domain I play with. Then I will shortly introduce Tekton and explain how to make it more powerful in particular circumstances. Okay, so what is AI lifecycle or MLOps? Some of you may know. Is there anybody who has developed machine learning model and is running in production? No. Okay, so this topic is new for you. I will cover it very shortly to make you familiar with some aspects. Like in software development, in machine learning, you play exactly with the same difficulties. So you need to have traceability, you need to have observability, you need to have metrics. Otherwise, you know nothing about your AI system which is running in production. And our team is mostly focusing on this area, and we are looking at the deployment of AI systems from the beginning. So from gathering data through model training, model deployment, up to monitoring. And even though you may be or you may hear about machine learning operations, something up to the area of model deployment, it's not so frequent that that people are talking about observability of the models, which is currently very important topic. At IBM Research, I have pleasure to cooperate with IBM Research team. We pay attention to different aspects of observability of AI systems. So we started discussion today about the trust, and with AI systems or machine learning, trust is, as we know, a very hot topic, and we can look at it from many different angles, from the security perspective, privacy, fairness, explainability, so a lot of stuff that you can look into. I would like only to mention about one particular area, which is security. You may find it useful to find if your model is secure for any kind of adversarial attacks. Why this topic is important for me for this talk? I want to use that particular metric or monitoring of model robustness as it is one of the heaviest from the processing perspective or resource consumption process. It is even heavier than training itself, because you need to retrain your model again and again on different data, on adversarial samples generated from your original training data. So that would be useful for me to explain it to you how in Tekton orchestration of such of such activities like monitoring machine learning models can be achieved. Okay, so that's a word of introduction to MLOps as a topic. Let's go back to our main topic, which is Tekton. Of course, I assume all of you knows Jenkins or any related or any similar CI/CD system like Travis or anything like that. Tekton is pretty new. Open source project developed by Google, and currently there are many contributors from different companies, including Google, IBM, and others. Our company is quite active in this area, and it is a building block for CI/CD systems. What I mean by that is you can use Tekton to build your own CI/CD systems. I don't know if you would be in the position to do that, but it is worth knowing that at least nowadays maybe Tekton is not at the same level as Jenkins, because for Jenkins you have plenty of UIs, plenty of different tools you can use with it, but still Tekton is very useful and is developing very rapidly. It is a CD Foundation project. It is a graduated CD Foundation project, so you can trust this technology. It wouldn't disappear accidentally. And it is known of its customizability and extendability. It is based on Kubernetes, so the same aspects from Kubernetes can be applied here, and it is also known of its reusability. I will cover that part lately. And like your Kubernetes cluster, you can scale your Tekton pipelines easily, but there are some pain points which I will cover. Okay. So this is a preview of some pipeline visualized from Tekton. There are plenty of tasks that can run in your pipeline. Usually in DevOps world, I usually seen pipelines which are rather sequential. You perform your build, you do some tests, you trigger deployment, and so on. In MLOps, usually the pipeline is much more complicated, and it constructs the acyclic graph composed of different tasks that are run in parallel, that can infer one with another. So Tekton for that plays a very good role. The pipeline in Tekton is simply a graph of such tasks. Each task in Tekton is constructed of sequence of steps. This is the preview. I don't know, I hope the font is big enough. This is the preview of a task definition in Tekton, so simply in the YAML format. Tekton is cloud native by design. What does it mean? Any resource that describes a pipeline or task or anything related is a Kubernetes resource. So in this case, we have task, which is a custom resource, and in such a task, you can define parameters, you can define results. Both are typed, which is nice. You can define your steps, which are based purely on the Docker image and some script. And you can play with workspaces, so you can mount some volumes, very basic stuff. Each task is collocated on your Kubernetes cluster, so steps can work on the same data easily. You will find in community plenty of tasks already defined for you, so you can grab them and reuse. That's quite nice. The format of the task and pipeline is kind of standard, so you can mix and match them and reuse in your particular pipelines. I would say much easier than in other tools like that. What you do when you want to run the pipeline, you simply create yet another kube resource, which is pipeline run, which takes care of executing the whole pipeline. So still we are on the level of Kubernetes resources, and such a run creates for you yet another resources which are named task runs. Pretty straightforward. And now a word of explanation how those items are mapped to kube resources. So each task is realized as a separate pod, and here we have the collocation, and each step in the task is executed as a separate container. So that gives you a quite nice separation between the tasks, but it also costs you a lot in your cluster, right? Because you need to pay for all those pods which are spawned up for the time being of the processing inside of your task. So that's perfect solution for heavy processing, but maybe not so good when you have some very lightweight activities. And I will go back to that in a second. There are many adaptations in community and commercial tools which are using Tekton. So this is the community project, Tekton dashboard, which gives you the quite nice UI to track the execution of your pipelines. Red Hat embeds Tekton in the operator named OpenShift Pipelines, which is nothing more than a UI layer on top of Tekton. You can play with Jenkins X, which can run on Tekton as well. So that's pretty nice. And finally, this is the screenshot of product I work on. So at IBM we use Tekton in many places. As an example, I'm mentioning here about Watson pipelines. And we are going smoothly back to our MLOps story. As I mentioned in the introduction, in MLOps story you usually talk about collecting data. So my example of the pipeline can look like on the screen, where I have multiple pre-processing steps, some process or task responsible for data joining, data quality measurement, and finally I can train my models and check model robustness for that. Okay, I would say I'm done. I run everything on my resources, on my Kubernetes cluster, I'm done. But then I may realize, oh, the monitoring of my model takes really long. It can last for days, and I don't really have enough power in my internal Kubernetes cluster. Maybe I want to offload this particular task to external server and a kind of serverless platform. That's a great idea, but now the difficulty starts, and let's discuss it in a second. So for the purpose of this demo, I selected IBM Code Engine as a serverless platform. There are batch jobs available there, and I implemented monitoring of my model in such a platform. I can define resources there. I don't have to care about maintaining the cluster. I pay only for the time when the job is being executed. Okay, but what can I do now to integrate it back with my Tekton pipeline? I can define task for this particular monitoring step. It's pretty simple. I can specify Docker image where I have a CLI tool, and there's a boilerplate to log into the cloud, and then I can invoke the single command, which is simply job submit. Nothing simpler than that. Yeah, so such integration is straightforward. What is the problem? if you remember how task is represented on the Kubernetes cluster, it spawns a separate pod. Okay, so during this long running process, I would have on my local cluster still allocated resources, which will simply perform this very simple question. Are we yet there? And really nothing more. Are we there yet? And this wait is something what I see in very many examples, right? We are spawning resources. Even though those resources can be minimal, still I need to pay for them, right? So if I'm running multi-tenant solution or when my workflow is really huge, I may run into problems with costs and efficiency with such approach. Okay, so can I go bigger with Tekton? Can I plan my trip for this year to visit Greece and Turkey and to spend on the road more than 6,000 kilometers? This is our plan, quite challenging, 72 hours in the car. We will manage with that. But what about Tekton? Would Tekton survive such pipelines and such scale? Would it be able to orchestrate thousands of tasks in a single pipeline? When I heard about those kind of requirements at the beginning, 2 years back, I was a little scared. Fortunately, there is a superpower in Tekton, which is named custom runs, which gives you the ability to orchestrate things slightly different and how it looks like. So custom task is equivalent of a standard regular task in Tekton. And you can implement for this particular task a regular Kubernetes controller. So I don't know how many of you have ever implemented controller for Kubernetes, any kind of controller. Nobody. Okay, so I will show you that's not so difficult, okay? You have your own custom resource, and the only thing you need to do in Tekton is you need to tell Tekton what is the state of your task, right? And what are the results that Tekton needs to populate to the pipeline to be available for their tasks for consumption. What are the very good examples of custom tasks which need no processing power? So there is really no sense to spawn separate pods for it, but rather use this approach. You may think about very simple stuff like evaluate expression. It can take nanoseconds to evaluate expression, but if you would spawn up the separate pod, the simple evaluation will take a few seconds, right? You may think about something simple like wait for all previous results or any of previous results, like, or wait for some file to appear, or wait for timeout, or run nested pipeline, or trigger some external system, Lambda function, whatever it would be, right? So those are kind of examples are very good for custom tasks. So let's look how we can implement them. We are starting with custom resource definition. If that's magic for you, I will only tell you that you need to name it. That's the most difficult part. And maybe you want to add some additional parameters which will describe your task. So in this case, I have a single parameter which is named job name. Okay, I need to know which job to run in case of my my pipeline or integration with the external batch system. That's reasonable. So that's how my custom resource is defined. And now I need to do the hardest thing. So I need to implement a controller which would be responsible for making sure that the state of a custom run resource, which represents my executing task, reflects really the state of the external job. Fortunately, this is a very known topic, and you will find a lot of tools which will help you. But a word of introduction how you usually do that. For this kind of development, Go for me is the best because there is plenty of tools available for Go, and all you need is you need to implement is something called reconciliation loop. So this is kind of a loop that monitors the state, but in the reactive way. I remember a few years back that there was a huge movement. Everything needs to be reactive. Now we have reactive CI/CD systems, right? So that's perfect. You look at your Kubernetes cluster state through kube client, which has cache. So you are good. You perform as optimal as possible, and you react on events coming from your cluster. Okay, sounds reasonable. You don't have to write the whole code. There is plenty of generators. One of the examples is Knative package. This is also the open source tool, of course, and it is used in Tekton and many other projects related to Tekton. So I can simply generate the code, and generated code already have something called informers injection, leader election, which is pretty important because I want to scale my controller. Okay, in the regular tasks, I had separate pods for each task, so they scaled with my pipeline naturally. Here I need to think about, okay, how I will scale the solution when the number of tenants would grow, right? So I can implement auto scaling with this approach quite simply. And other stuff related to observability. If you were on the previous talk, you would know what I'm talking about, and I will show you that in a second. Okay, so going back to our example, we are integrating Tekton tasks with external job system. Fortunately, in case of Code Engine here, I have access to Kubernetes API from this serverless platform. So I can simply join those two clusters together in my reconciliation loop and look at the state of resources in both clusters. So simply I can synchronize the state of my batch job with the state of my custom run. Okay, and I don't ask you to read this code, but I have 3 code snippets. Those are the 3 main methods. The boilerplate for the reconciliation loop, the method which is responsible for triggering the batch job in the external system, and the method which is responsible for synchronizing the state. If they fit into the single screen, I think they are clean enough. So it wouldn't take you very long to learn how to implement such stuff. Okay, and finally we are getting in our kube cluster, so we can look at the resources there. First 3 pods are part of my extension, Tekton extension deployment. So I have controller and webhook there. Resources are pretty small, so I don't pay much for this solution. Here you can see how Tekton deployment looks like, which is still which tends to be very small. Of course, it depends on the load you will put on the cluster, but you can even deploy Tekton with some MIDI cores for basic stuff. And this is the preview of timeline of not exactly the same example, but to give you some notion how quick we can go with this approach. Okay, so here we have 5 separate custom runs coming from 5 separate tasks, and as you can see, the whole pipeline took more or less 800 milliseconds. So each particular task takes less than few hundred milliseconds, which is good for CI/CD system, definitely, in comparison to spawning up separate pod and then taking care of all the resources. Are we still there? I don't see you are sleeping. Fortunately, my children when we are traveling are sleeping in the car, so I can wake them up when we are at the place, and that applies to our reconciler. It can be reactive on the events coming from the cluster rather than asking me when I'm driving if we are there yet. Okay, so at the very end, I will like to show you a quick demo how it works in practice. So let's see, I'm not logged into the UI, so I will copy token for that. This is my local cluster. I'm running Minikube on this machine. Those are the custom resources which are defined in Kubernetes cluster. So you can see that I have pipeline there, I have task run, and pipeline. So those are the default or the custom resources which are pre-installed with Tekton itself. And I have this custom task name called engine task, which I presented to you. So the definition of this task is pretty straightforward. So as I mentioned, nothing really complex. The most difficult part is to name it properly. Here is the preview of the external system, so the serverless platform, and we can see that we have some jobs already executed there. And the word of explanation about traceability. This is also a bit of my personal effort to enable nice traceability for Tekton Pipelines. I'm working with community to make this tool officially available as an open source extension, but as a spoiler, I can describe how it works currently. So the line at the top represents the execution of the overall pipeline run, and you can see then the measurements for particular tasks. You can go deeper to the particular reconciliations, so the single iteration of your loop, and even lower you can go to your API calls. So you, with simple trace ID which can be generated for your pipeline, you would be able to trace the execution from top to bottom, which is very important when you are paying attention to performance, of course. This is more a complex example from the real world where I was analyzing the performance of one of the pipelines. So I don't know how frequently you look at your CD pipelines to this level of detail, but for me it was quite important to make them optimal. Okay, I think we are at the time, right? 3 minutes left. Okay, so if you would be interested, there is a blog on Medium where I put some information, so you can simply look there, and you will find some of those examples in my GitHub account. So yeah, feel free to reach out to me if there would be any question, or you can ask it right now because we still have 2 minutes left.